Hello everyone, welcome to the first video in the SQL Challenges and Concepts series. I am Saharsh Bhatnagar, founder of Stellar Smart Academy. This video series is for those who want to learn SQL concepts through realistic scenarios and situations. The very first thing that we do when we start learning SQL is to understand how we write the syntax, how we write basic queries, be it select queries or queries that involve the where clause and many other such things. But it's more important for us to understand when and where do we use the different concepts in SQL. And the best way to do this is to undertake or go through realistic scenarios, real life scenarios, wherein we are using these SQL keywords. So without any more delay, let's get started and see what's our challenge for today. So our today's challenge is to determine how many rows do we get in the output when we perform 5 types of joins between two tables. So the concept tested here is to develop a deeper understanding of how different types of joins work in SQL. For our demonstration purposes, we have two tables at hand, table A and table B. Both of these tables have a similar structure. That is, both of them have two columns, AID A unit and BID B unit. As you can see, both of these columns have integer values in both the tables. So if you are a beginner and you want to learn how different types of joins work, this is the best time to pause this video, try to determine the number of rows on your own, and then follow along this video to determine if you got the answers right. More importantly, this video is aimed so that you can develop a better understanding of how different types of joins work. So what is the strategy that we are going to use in order to be able to answer correctly for the different types of joins? What we have done is we have designed an algorithm for each type of join. As we all know that an algorithm is nothing but a set of predefined steps in a specific order. If we follow each step correctly, then we are sure and confident about each join. Thus, if we follow these steps of the algorithm duly without diverting, I can guarantee you that you will be able to solve each type of join and use each join with more confidence. More importantly, these joins have been designed in such a way that it's pretty similar, pretty close to how SQL actually performs these joins in the background. So now it's time for us to do the hands-on for this challenge, and for this purpose we will navigate to SQL Server Management Studio. So here we are in SQL Server Management Studio. As you can see, I have two tables here, table A and table B. The create scripts and the insert scripts for these two tables have been provided in the description of this video. So you can navigate to the link specified there and get the create and insert scripts from there. I'll just expand these tables to show you the two columns that I was talking about earlier in this video. You can see column A has AID and A unit. Similarly, the table B has the columns as BID and B unit respectively. So I'll just do a simple select star from statement for both of these tables in order to show you the data present in these two. And there you go. This is the data that we have in both of these tables, table A and table B. So around 7 rows in table A and 5 rows in table B. Alright, so now that we have our things set up, let's go to the first case that we have over here. So case 1 is to understand how inner join works between two tables, and for this purpose we have written an algorithm. What is the algorithm? Let's go through it. Step number 1. Please follow this diligently. For each row of the first table, that is table A in our case, compare it with each row of the second table. So let's say we fix the first row of table A, we take one value from the first row of table A, we need to compare this value with all the rows of table B in that order. So when we are performing the comparison of the two values, we obviously have two options. Either the two rows will have equal values or they might not be equal. Since inner join is only and only worried about getting the equal values or comparable values, we will add only those values that are equal to our output. In case if we find a value in table B which does not match with the table A's value, in that case we will skip the row and move to the next row of the second table. So till when should we perform this process? We should continue comparing the two tables till we reach the end of the second table. And finally, we need to repeat these steps for each row of the first table. Once we have done, the output we get is the required output for the inner join. So let's try to understand this by going back to SQL and see what exactly do we mean over here. So now I'm going to write a simple statement between A and B by writing a join. So the first thing is I write select, and then I want all the columns from both the tables. So I will say star, and then I will say from the first table, table A. Then I will write the keywords inner join. Then I'll write the name of the second table, which is B. And now I need to write the column on which these two tables are being joined. What is that column which might have same or equal values between the two tables so that I can join them? So in our case, from table A, we have A underscore unit as the column. And from table B, we have B underscore unit as our column. So when I run this query, I get 13 rows. Now let's see if SQL Server really did what we were trying to do. So before running this query again, let's go back to the original queries of table A and table B. Now if you remember the algorithm of inner join, I said let's take one value from the first row and compare it with all the values from the second table. So we'll take first value, the first row from the first table, which is 1 in this case, and then we will compare if this one has any matching values in the column B unit of the second table. As you can see, the very first row matches, therefore this row will be there in our output. But here is the most important point of this entire video. Whenever we are performing a join and when we find a matching value, we should not stop looking for other values. That is the most common mistake that people do. Whenever they find that two values are equal, they just note it down and then move to the next row in the first table. That is the biggest mistake of performing a join. Whenever we find a value which matches in the second table, we must note it down for sure, but we must continue searching for the remaining rows and find values that have a match. So in our case, once we have noted down that this one from table A matches with this one from table B, we note it down separately and then we continue looking for the next row. So our next row is 6. Now we know that 1 and 6 are not equal, and as per the algorithm we need to skip the rows that are not equal and move to the next row. So now we come to the third row. Remember, the value being compared is still the first row from the first table, which is being compared with the third row from the second table. Since you can see 1 and 1 again have equal values, and our algorithm says that whenever we find a match we must note it down. So we also note this row down. So till now, if you guys are following along, we have two rows that have a match. But again, the algorithm says that once you find a match, move to the next row. Keep going till you reach the end of the second table. So now we will compare 1 with the fourth row of table B, which is 7. Now you can see 1 and 7 do not match, and our algorithm says whenever there is a non-match, you need to simply skip and move to the next row. So here I am at the last row of table B, and you can see again 1 and 1 match. That means we need to note this down in the output. Another important thing to note, we have reached the end of table B. So all the comparisons have been done for the first row of the first table. If we check our algorithm, it says move to the next row of the first table once you have reached the end of row for the previous one. Since we have already compared all values for this first row with all values in table B, it's time to move to the next row of table A, which is 5. Now we follow the same process as we did. So first we compare 5 with the first row of table B, which is 1. Since this is a non-match, we ignore the output, we ignore the row, and we move to the next row, which is 6. Now we compare 5 and 6. Again, you can see it is a non-match, so we skip this row. Then we move to the third row, 5 and 1. It's a non-match, so we skip this row. We come to row number 4, which has the value 7. 5 and 7, it's a non-match, so we move to the next row. 5 and 1, it's a non-match, and we have also reached the end of the table. So 5 does not have any matches in table B, and therefore this row will not be appearing in our output. Since we have reached the end of table B, we will move to the third row for table A and then perform the same steps as we did for rows 1 and 2 of table A. Thus you see, let's go back to the output that we had got. You can see that's exactly how they have done. So SQL follows the same thing. SQL started from the very first row of table A and tried to find out if they have any matches in table B. And you can see this one found so many matches here. And similarly, it moves on to the next rows of table A. Since there was no match for 5, there is no entry for 5. And then it continues and performs the same matching, you can see. And that's how we get 13 rows. So if you have any doubt here, you can go back, rewind the video, and look at the steps of the algorithm and try to do these steps again manually on your own to have a better understanding, as I explained on how inner join works. So this is the core idea of how join works. Now, a very important thing that I want to bring to notice is the fact that a lot of people get confused between inner join and intersect. Now, this confusion is pretty normal to happen. Why? Because inner join returns, matching values, so values which are common between the two tables. And when we have studied Venn diagrams, or when we learn the concepts of intersect, union, we also find that the region in between the two Venn diagrams is the common area or the common region and the common records. That's why we confuse ourselves between inner join and intersect, because both of them involve common number of rows. Now this is the slide that tells you how inner join is totally different from intersect. Inner join will always return all the match values, like we saw in the previous example. No matter we found a match between the one from the first table in the second table, remember, as I had told earlier, we did not stop. We continued to look for one in the second table. And that is the beauty of inner join. We never stop looking for matches. We continue to look for even more matches till we reach the end of the table. On the other hand, if we talk about intersect, it's only concerned about finding one match. As soon as it finds one match, as soon as it finds one which has a match 1 in the second table, it does not look for any more similar matches. So the entire idea of intersect, which we will also see in the upcoming videos, is that intersect only keeps one original copy of the matching rows. So if it finds 1, 1, it will only keep one row. It will not bother to include the remaining occurrences of 1, 1, no matter there are many in our scenario. So intersect will always exclude the duplicate values and keep only one original copy of the matching rows. That is the core idea behind inner join versus intersect. Let's come to case 2. So case 2 is about performing a left outer join. Now let's try to see first what is the algorithm. How do we perform a left outer join? So the very first step is perform the inner join algorithm on the two tables. So you can see the algorithm for left outer join has the first step as performing the inner join algorithm, and we have already gone through that. So if you remember the steps for inner join algorithm, all you have to do is follow those steps first. Once you have completed the first step, which is to follow the inner join algorithm, you will have all those rows which have equal values on the join columns, right? Now the question is, what do we do for the non-matching rows? Now remember, this type of join is a left outer join. So the table which is on the left of the keyword left outer join is the left table, which in our case is the table A. and the table on the right of the left outer join keyword is table B. So we need to include all the non-matching rows for table A, right? So our base table is going to be table A. Since we have already performed the inner join algorithm in the first step, we have all those rows which are common in A and B. But left outer join says that we must also include those rows which are not common between A and B, but only those rows which are belonging to the table A. So we will capture all the values first from the inner join algorithm, and let's call it set A. The second step is, for every row of the first table that was in the non-match category, we will simply replace the right table value as null. Okay, we'll see this when we perform the example in a couple of seconds from now, but understand the algorithm here. So the first one is to perform the inner join algorithm. From that algorithm, we will get set A, which is nothing but all those rows which are equal between A and B. But the question is, what do we do with those values of A that do not have a match in B? For those tables, we will simply replace the right table value with null. We repeat these steps till we have compared each non-matching row and have assigned a null correspondingly for those rows in table A. And we call these set of rows set B. So finally, the output, which is set A plus set B, is the required output of the left outer join. So without any delay, let's head back to our SQL Server, and let's see how are things in SQL Server for left outer join. Alright, so in SQL Server we have already done inner join. Now we are simply going to replace the inner keyword and we will write left outer join over here. Remember, the condition on which the join is being performed remains the same, that is a.aUnit is equal to b.bUnit. Now let's run this and we get an output like this. Now if you see over here, what's actually being done is, if you ignore these rows, that is the rows having nulls for the time being, you can notice that out of 15 rows, 2 rows have nulls, right? And if you remember, in inner join we got 13 rows, whereas in left outer join we have got 15 rows. That is basically 13 rows from inner, which was set A if you remember, and the remaining 2 rows are from the left join, which is your set B, right? So you can see here that we have performed the left outer join by following the algorithm, which is first extracting all those 13 rows that we get by performing an inner join, which you have already seen, and then performing the join for 2 rows that do not have a match. Let's determine what these 2 rows actually are. You can see over here we have 102 and 5, which is coming from table A, and these rows do not have a match because if you remember, 5 does not have any value. 5 does not have a value 5 in table B, and therefore the values are null. Remember the algorithm, it says to replace null. Similarly, if we see the value 9 in table A does not have an equal value in table B. So let's quickly check table A. This is table A, and let's run these 2 queries together so that we can quickly understand. You can see here 5 does not have a match in these values. Out of 16171, none of them equals 5. And since, if you remember the rules, table A is on the left side of the left outer join clause, therefore table A is our base table, and we need to note down all the rows that are matching as well as non-matching for table A. We are not concerned about table B at this time. So we know that 1 and 7 are 2 values which have a match, but 5 and 9 do not have a match over here. So that is why we will simply note these values down and call them set B. So 5 does not have a match, 9 does not have a match, and that is why for 1025 we need to simply put nulls for the rows coming from B, and we know that table B is nothing but 2 columns, BID and BUnit. So for 1025 the values for BID and BUnit will be null, and null. Similarly, for the row 1059, since 9 does not have a match, the value for BID and BUnit will be null, comma null. So if we quickly go back to the left outer join, you can correlate on the explanation I just gave, and you can tally that this is totally following our algorithm, and this shows that our algorithm is foolproof. It works in all kinds of scenarios. So this is the logic for performing a left outer join. And now let's quickly proceed to the next type of join, which is the right join. So let's look at the algorithm for the right join. What is in store for us when we see the algorithm for right outer join? Well, it's totally the same as the left outer join with a minor tweak. And what is that minor tweak? We have simply replaced the terms first table and second table. We'll see that thing in a moment. So what's the first step for a right outer join? Well, the first step remains the same as it was in the right outer join, as it was in the left outer join, which is to perform the inner join algorithm on the two tables. So firstly, we need to simply get all the rows that have same values from table A and table B and note them down together and call them set A. This is exactly what we did when we were doing the left outer join also. Now the second step is to perform or to simply get those rows in the second table. Now if you are writing right outer join, remember the table on the right of the keywords right outer join is the right table. So in our case, table B is a right table, and just like we had table A in left outer join as the base table since it was on the left, similarly we have table B as the base table which is on the right. And remember, base table means the table such that we need to find the matches and non-matches for all rows of table in the base table, that is table B. We are least concerned about individual rows in table A. Alright, so the first step was to perform the inner join between A and B. The second step is that all the values that are left out in table B, which is the right table, we need to simply replace the non-matching values with null. This is exactly what we did in the left outer join, if you remember. And lastly, we need to repeat this step for all the non-matching values, and what we get is set B. So the final output is nothing but set A and set B. Alright, so let's quickly go back and check how we have things in SQL Server. Alright, so now we are going to replace the left keyword and call it right outer join. And remember, anything on the right of the keywords right outer join acts as the right table, which is our base table. So we need to look everything from the perspective of the base table. So let's first quickly run with the queries again and see what we had in store. So if you see now, the first thing is we need to form set A. Set A is the common values between table A and table B. Now you can see 1 has matches in table A. Similarly, we can see that 7 also has matches in table A. Alright, but the value 6 does not have a match in table A, and that is the reason why you will see that in the output of right outer join between A and B, we will see a row which says 202, 6, null and null. Why? Because 6 does not have a match, and our algorithm says that for a non-matching value, simply substitute nulls for the remaining two columns coming from table A, which is a reference table, the non-base table, right? So let's quickly do the right outer join here, and now you can see we have 14 rows. So how did this 14 occur? Well, I guess you must have figured it out. Since we know that right outer join is nothing but the sum of set A and set B, we know that set A, which is the inner set, that is the set containing the equal values, has 13 rows. We already know that, and there was only one row which was coming from table B for the value 6, which did not have a match. So this becomes 1 and the total becomes 14. This 14 totally justifies why we got 14 rows over here. That is 13 rows for matches, as we already know from inner join, and 1 row for a non-match coming from table B. And you can see here, since the order in which we have written this select query is A right outer join B, therefore the columns of table A appear first, as you can see AID and A unit, and then we have the columns of table B, which is BID and B unit. Alright, so this is how the right outer join works. Now, if you think from a programming perspective, I would suggest that you also take note of a very important thing that I have over here, which is if we write down the algorithm for left outer join and right outer join, don't you think that these algorithms are mirror images of each other? The only difference is we are simply substituting or swapping the tables first and second, right? So can we say that the algorithm for left outer join is nothing but a complement of the algorithm for the right outer join? And by complement, I mean that if you are using the word first table in the right outer join, you will call it the second table in the right outer join, and if you are using the keyword second table in right outer join, you will simply call it the first table. So simply you have to swap the keywords first table and second table in the algorithm for right outer, and what you get is exactly the algorithm for left outers, right? So let's see exactly what I'm trying to say here. You can see in this image AID and BID are being compared, and you can see we have right outer here. So if I am saying that there is a table A and a B which are being compared on AID and BID, and I'm doing a right outer, this is exactly same if I swap B, I swap A, and I perform a left outer join. And there you go. So right outer join is nothing different from left outer join when it comes to the steps of the algorithm. They are totally the same. They follow the same order. The only logical difference is since left becomes right, we swap the keywords first and second. The functioning and the order of the algorithm remain totally the same. Therefore, if someone asks you, do you know how to do a left outer join? And if you're confident in doing a right outer, you can very well use a right outer join to perform the left outer join and vice versa. So I hope you are able to understand the point I'm trying to make over here. Alright, so let's come to case 4, which is a full outer join B. Now, a full outer join basically behaves by combining the concepts of inner join, left outer join, and right outer join. So basically, if I were to write the algorithm of full outer join, let's see what all steps do we have here. The very first step is to perform an inner join algorithm on the two tables, and we call that set A. So the very first step is what we have been following along in the previous two joins, which is left join and right join, and that is to simply list all the matching rows between table A and table B by performing the inner join and calling it set A. But that's not all for full outer join. Full outer join is a combination of all the matching values that is being captured here in set A and all the non-matching values. Now if you remember, if we are joining two tables, tables A and B, there can be some values which are present in table A that do not have a match in table B, which is captured by the left outer join. Similarly, we will have some rows from table B that do not have a match in table A. This is something that is captured by the right outer join. So that's how we have the steps for full outer join also. After performing the inner join between A and B, we perform the second step of the left outer join algorithm. If you remember the second step of the left outer algorithm, it is to simply substitute null for all the non-matching rows of the left table, which we are also calling the first table, in our case table A. All the rows that are in table A that do not have a match in table B, we will simply take those rows and substitute nulls for values coming from B. Alright, and this set of rows is called as set B. And finally, we need to also capture those rows that were in table B that do not have a match in table A, and that is the reason we will perform the second step of the right outer algorithm, that is substituting nulls for all the non-matching rows of the right table, which we are also calling as the second table. So all the rows of the right table, that is table B, that do not have a match with the rows of table A are captured and null is substituted, and we call it set C. And as you have rightly figured it out, a full outer join is simply the combination of set A, set B, and set C. So if you are really thorough with the algorithms of inner join, left outer join, and right outer join, you will notice that full outer join behaves by extracting the steps from inner, left, and right algorithms respectively. It is nothing new at all. It is totally the same thing that we have been doing. It's just that the steps now have been combined, and the output is set A, which is inner join output, set B, which is the left join exclusive rows, that is all the rows that do not have a match coming from left table, and set C, which is all the rows that do not have a match coming from the right table. A very important thing to note here about full outer joins is you can perform this algorithm by swapping or flipping the steps, that is step number 2 and step number 3. So if you want to perform the full outer join algorithm, what I can do is I can perform the inner join algorithm first. That is something that I always do, but instead of performing the second step of the left outer, I can perform the second step of the right outer algorithm, and we can call that set B. And then finally we can perform the second step of the left outer algorithm, and we can call that set C. So basically set B and set C are not fixed. There is no rule that you have to perform the left outer algorithm first and finally the right outer algorithm. If you want, you can switch the steps. You can perform the right outer algorithm first, call it set B, and perform the left outer algorithm finally, call it set C. In any case, the output remains the same. And when I say the output remains the same, I mean that the values of the rows and the number of the rows remain the same. The order of the rows can vary, but the values and the number of rows remain totally the same. So coming back to SQL, you can see, let's quickly write full outer join over here. Now when I'm writing full outer join over here and I try to run this query and get this output, so you can see we have 16 rows in total. Now if you guys remember, we have already seen right outer join before, and we know that we got 14 rows over here. And if you remember, for left outer join we had two values, which is 5 and 9, which were having nulls. So if I try to write this thing properly, what I am trying to implement or say is 13 rows are common, which are coming from the inner join. 2 rows, if you remember, were returned when we did the left join, and these were the non-matching rows. So I will write non-match here. And 1 row was returned when we did the right join, which we just did a couple of seconds ago, and this is again a non-match. So 13 rows which give a match, 2 rows which give a non-match, and 1 row which gives a non-match. The total being 13 plus 2 15 plus 1 16, and there you go. 16 is rightfully what we are getting from SQL Server as well. So what has SQL Server done? It has followed the exact same algorithm. First, it performed the inner join and it got all those rows which were equal between table A and table B, that is 13 rows in total. And then what SQL did was it tried to get all the rows for the left join, and if you remember, table A had 2 rows which did not have matches in table B. So these are the rows that I'm talking about. And finally, it performed a right order join between table A and B by simply getting those values in table B which did not have a match in table A. And you can see this row, remember 6, does not have a match in table A, and that's why you can see these nulls. So that's how we get the total of 16, which is the sum of inner plus left outer plus right outer. And that's how we get 16 rows in total. If you have any doubt over here, you can anytime visit the algorithm again and try to perform these steps manually again in order to have more clarity. Another important point that I want to state over here is that you can very well flip the order of the second and third steps. That is, you can first perform the inner join then perform the right outer join, and lastly you can perform the left outer join. So you can change the order. So you have two orders now. The first order is you perform the inner join, then you go for the left outer, then you go for the right outer. And option number two is you perform the inner join, you go for the right outer, and lastly you go for the left outer. In both the algorithm steps, the output will remain the same. The order may vary, but the output, that is the rows, will remain the same. The rows might appear in a different order, but the number of rows and their values will always be accurate and correct when we perform full outer join between A and B. So that is the core idea of full outer join. Lastly, let's come to the fifth type of join, which is a cross join. Now, cross join is a type of join which doesn't really value the concept of join as a whole. The concept of join is if we find a column that is common between two tables, that has equal values between two tables, we join them and we extract all that we can from both the tables, right? But a cross join is basically the point where we simply use pure mathematics to return the number of rows between the two. So how do we perform the cross join? Here is the algorithm, right? For every first row of the first table, in our case the first table is table A, since it is written on the left of cross join, we return all the rows of the second table without comparing the values being joined, right? So there is no need to check if the value of the row in the first table matches with the value of the row in the second table. There is no need to perform any comparison. Unlike all the joins that we have discussed so far, we were performing comparisons. We were checking if the values are matching or non-matching. Cross join does not worry about all this. All it has to do is you take the first row of first table and join it with each row of the second table. And once you are done, you repeat these steps for all the rows of the first table. So what I'm trying to implement from a mathematical point of view is that if we have P rows in the first table and if we have Q rows in the second table, the cross join is simply returning the product of the two rows in the final output, which is P into Q rows. To understand this, let's quickly head back to SQL Server. So in SQL Server, when we want to perform a cross join, we won't be writing the keyword cross join. All we can simply do is write select star from A comma B. We can write this. This will return a cross join, or we can also write select star from A cross join B on A dot A underscore unit is equal to B dot B underscore unit. Now I'll tell you the reason why I'm writing this query. Let's first try to run this query. What happens when we run this query? When we run this query, we get an incorrect syntax. Why? Because I mentioned this thing a couple of seconds ago, that cross join does not worry about the values being equal or unequal. It is simply the permutation by taking each row of the first table and merging it, or creating a combination with each row of the second table. Alright, so if we perform a cross join now, you can see the query works totally fine because there is no need of any join condition. And if you remember, we will quickly run the two queries first. So if you remember, we had 7 rows in the first table and we had 5 rows in the second table, table B. So by our calculation, if table A has P rows, where P is 7 in our case, and table B has Q rows, so Q is 5 in our case, the cross join will return simply P into Q, which is equal to 35. So let's see if we get 35 rows. So we'll quickly run this, and there you go. You can see the total over here. We have 35 rows in total, and you can see it follows pretty much the same algorithm that we have designed. It takes each row of table A and creates a combination with all the rows it finds for table B, and it continues to do the same for all the remaining rows of A. So it's simply a combination. You take each row of table A and you merge it with each row of table B. Let me reiterate the point I'm trying to say here in case you have any confusion. Each row of table A, that is 1, will be combined with each row of table B. So we will have 1 comma 1 as one row, then we'll have 1 comma 6 as one row, then we'll have 1 comma 1 as one row, 1 comma 7 as one row, and finally 1 comma 1 as one row. So totally you can see for one row in table A we will get 5 rows from table B. So for if one row we get 5 rows from table B, then for 7 rows we get 7 into 5, which is 35 rows from table B. So there is no concept of comparing the values here. It's purely and purely a permutation logic between the two tables. Let's try to run this query, which is select star from A comma B. Now you can see this pretty much does the same job that the cross join query did, the query with the cross join keywords did, which is simply combining each row of table A with each row of table B. Now you might wonder there is no join keyword written here, but let me tell you one thing. What exactly is a join? A join is nothing but it's kind of a where clause wherein you are specifying that column 1 equals column 2, right? So if I were to write a inner join query without using the inner join keywords between table A and B, can't I write something like this? I can write select star from A comma B, where A dot A underscore unit is equal to B dot B underscore unit. And if I run this, if you remember, we had 13 rows in the inner join, and here you go, you have the same number of rows, the same values of rows in fact, coming from this query. So all I'm telling SQL is that you have been given two tables and you need to get all the columns from both these two tables, but you need to filter the rows only when the value for A dot unit from table A matches the value of B dot unit from table B, and this is exactly what the inner join query was implying. So the same lines, if you remember, cross join does not care about values being compared, so the where clause is eliminated, and that's why this query behaves the same as the cross join query. That is, the select star from A comma B behaves the same as the cross join query. So this was the overall idea of going through each and every type of join, and that is the end goal of this video. So if you have any doubts, you can post it in the comment section, but please do like, subscribe and share this video. Thank you for watching, and we'll be back soon with yet another video. Take care, guys.